Hello and welcome to All Chemists. Today we are going to study about equilibrium. For equilibrium, there are so many factors that can affect equilibrium, including temperature, pressure, volume, and concentration. Now let's start with temperature. Temperature can increase or decrease. So if temperature increase in my reaction, equilibrium will shift to the endothermic direction. Endothermic direction, which means the positive direction. And if temperature decrease, equilibrium will shift to the exothermic direction. Now we will go back to one of the reactions and try to see if the reaction is going into the endothermic direction or exothermic direction according to the temperature. Remember, if temperature increase, endothermic. If temperature decrease, exothermic. In this reaction, he's telling you directly that the forward reaction is exothermic, which means this part is exo, and the other part should be backward, going backward is endothermic. Now, if temperature increase, we said before, if it's gonna increase, it should be shifting to the endothermic direction. So in that direction, you will find nitrogen dioxide. So the reaction, it will shift forward the reactants. So the reaction will produce more nitrogen dioxide. Temperature decrease, it will shift to the exothermic direction, which is N2O4. Now he's telling you if temperature increase, it will shift to the left part, which is endothermic. So NO2 will be reduced. Now let's talk about the second factor, which is changing pressure. Pressure can decrease or increase. All we have to know which side the equilibrium will shift. If changing pressure increase, if I added extra pressure or external pressure, the equilibrium will shift to the side with the fewest gaseous molecules, which means this is the less number of molecules. And remember, this is molecules. Now, if it's gonna change to the other side, which means the changing in pressure will decrease, the equilibrium will shift to the side with the most gaseous molecules, which means this is more or less, yeah, correct, more number of molecules. So if it's increasing, less; if it's less, more. Now let's go back and apply our knowledge to answer this question. For this equation, chemical equation, as you can see, the number of molecules for nitrogen dioxide is 2, while on the other hand side, there is 1 molecule of N2O4. This is gaseous state, so I can't really compare according to the gaseous state, but I can really compare about the number of molecules. Now the question is, what will happen if the pressure is increased? If the pressure increased, we said before increase less. So it will shift to the products, yes, correct. The less number of molecules right there. And what will happen if the pressure decrease? Yes, more. It will shift to the more number of moles, which will be for more reactants than products. So the equilibrium will shift to reduce the number of molecules. Here to the right side, only 1 molecule, more N2O4 will be produced. For on the other hand side, if decreased, more NO2 will be produced. Now let's go to the third factor, changing in concentration. So the third factor here, the change in concentration, and how it will affect the changing in equilibrium. If concentration increased on one of the sides, equilibrium will shift to the other side. So it's in the opposite direction. So if concentration increased at the products, for an example, so equilibrium will shift to the reactants. And if concentration decreased at the products, so equilibrium will stay the same side where concentration is decreased. Now let's practice here. In this reaction, chlorine will react with iodine chloride to form iodine trichloride. Now let's practice on concentration. What if concentration increased here? What will happen? yes, it will shift to the other side, where it produces more chlorine and iodine chloride. Now, what if concentration decrease? Yes, it will stay the same to form or to produce more iodine trichloride. I hope that you have enjoyed our video for today and you have learned something about chemical equilibrium. Don't forget to like, share, and subscribe. See you next time.